Find the solution of the given initial value problem in explicit form. So we should write the final answer as y equals some function of x and determine the interval in which the solution is defined. Okay, so let's first solve this ODE, ordinary differential equation. So let's separate the variables. Y dy equals 1 minus 2x dx. Let's integrate both sides. We get 1/2 y squared equals antiderivative of 1 is x minus antiderivative of 2x is x squared plus c. Okay, let's say c1 for now. Multiply both sides by throughout by 2 just to get rid of this fraction. So multiply throughout by 2, we get y squared equals 2x minus 2x squared plus 2c1, and I'm gonna call that as c. Okay, new constant c is in fact 2c1, and we need to solve for y. So take square root both sides, so y equals plus or minus square root of 2x minus 2x squared plus c. Okay, let's use the initial condition, okay, this initial condition, and find the value of c. So using y at 1 equals -2, we get y is -2 when x is 1. Okay, y is -2, so -2 equals plus or minus. We will choose the sign square root of 2 times x. X is 1, so 2 times 1 2 minus 2 times 1 is squared, again 2 plus c. Okay, so -2 equals plus or minus square root of 2 and minus 2 cancel, c. Let's see, we are trying to solve for c. Square both sides, we get -2 squared, so this is squared, that's 4 equals just c, so c equals 4. Thus the solution here, y equals plus or minus, we need to determine in a moment. We'll determine which sign is correct in a moment. Plus or minus 2x minus 2x squared plus c. C is 4 plus 4. Okay, this is not the final answer, by the way, because we need to determine which sign works. For that, we use the initial condition again. Y1 equals -2. We need to get y equals -2 when the x equals 1. So using the initial condition, y at 1 equals -2 again. Y is -2 equals plus or minus, plug in the x equals 1, so 2 times 1 2 minus 2 0 plus 4. So -2 equals plus minus is square root of 4. Square root of 4 is 2. So to get -2, we need to pick negative sign. So negative sign is the correct sign. So the solution is y equals not plus or minus, just the negative sign, 2x minus 2x squared plus 4. So we are halfway done. This is the solution of the given initial value problem. Okay, next we need to determine the interval in which the solution is defined. Okay, we need to find the interval. Obviously that interval should include this 1, okay, where this solution is defined. First, notice that from the given question, dy over dx equals 1 minus 2x over y, because we are dividing by y, so y cannot be equal to 0. There is one restriction, so y cannot be equal to 0. Let me put somewhere here, y cannot be equal to 0. Okay, let me go down. Now we want to find where this solution is defined. This solution is given by square root of something, 2x minus 2x squared plus 4, and square root is defined for non-negative numbers. So this number, this expression inside should be bigger than or equal to 0, but it cannot be 0. When this expression is 0, we are going to get y equals 0, and we already said y cannot be equal to 0. So this expression for the solution to be defined, to make sense, the expression 2x minus 2x squared plus 4 should be bigger than or equal to 0, but this cannot be 0 because y cannot be equal to 0. Go back and see the original differential equation. We are dividing by y. We have 1 minus 2x over y, and y cannot be equal to 0. So this should be positive. Now we want to solve this rational inequality. Okay, to solve we need to factor left hand side. So let me write this in standard form. So negative 2x squared first plus 2x plus 4 bigger than 0. We can factor at the same time. We can pull negative out, just 2 out, negative 2 out, negative 2, then x squared negative x negative 2 bigger than 0. Let's divide by negative 2. Divide by negative 2, we get x squared minus x minus 2. When we divide by negative number, then we need to switch this inequality. So 0 over negative 2, which is also 0. So we should have x squared minus x minus 2 less than 0. We need to solve this rational inequality. For we factor this x squared x 2 times 1 2 to get minus is minus plus. So from this we get 2. So we need to test 3 intervals, because this expression is 0 when the x equals 2. Somewhere here 2, this is positive infinity, negative infinity, and from here we get negative 1. So negative 1. So we need to test 1 2 3 intervals where this factor, I mean this expression, this polynomial is less than 0. So we'll pick a representative in each interval and plug in here. We need to get the product of these two things less than 0. So let's try with this interval. Let's pick the sample point, any test point x equals 0, test point 3, and test point any number in between here. So let's take negative 2. Take x equals 0 and plug in here. So we are plugging in this function, by the way, just the left hand side, x minus 2 x plus 1, and we want the value less than 0. Okay, when we plug in x equals 0, this is 0 minus 2, negative 2, 0 plus 1 1, negative 2 times 1 is negative, so this value will be negative. So I'm going to put negative negative. Let's plug in 3 minus 2 1, so this will be plus plus, and here is negative 2, negative 2 minus 2 negative 4, and negative minus negative 2 plus 1, negative times negative positive. So this expression, this polynomial is less than 0 here, negative 1 and 2. So the solution is defined on this interval, okay, negative 1 to 2. The solution is defined on negative 1 to 2, and this is strictly less than 0, so we cannot have bracket. This should be parenthesis. And by the way, our initial point, the x value of initial point should be here. If you go up and see, the initial point was y1 equals negative 2, so this one should lie inside here, and that's the case. So final.